Welcome back. Today we're going to talk about functions and their inverses. Okay, so the inverse of a function, what it essentially does is it takes the operations that happen in the function and it undoes all the operations. Just like when you have the inverse of an operation. So subtraction and addition are considered inverse operations to each other because one undoes the other one, okay? So the inverse is what you do is you want to interchange the input and output values of the function. And we use a certain notation when we talk about functions. We actually write the function with a little -1 as in the exponent position. So this right here looks like it's an exponent, but it's actually not an exponent. It's just the notation that we use to write the inverse of the function. So this notation together is read as the inverse of f of x. Okay. So in order to get the inverse of a function, you're going to follow these steps. So let's say that we're going to get the inverse of f of x is equal to 1/2 x plus 3. The first thing you're going to do is you're going to take away the function notation and you're going to switch it with the y notation. So we're going to write this as y is equal to 1/2 x plus 3. Okay? Now the second thing that I want you to do is I want you to solve the equation for x. So take this, and right now it's solved for y. I know that it's solved for y because y is by itself on one side of the equation. So right now I want to solve it so that x is isolated, not y. So let's subtract 3 from both sides. So we have y minus 3 is equal to 1/2 x. To get rid of this 1/2, I'm going to go ahead and multiply by its reciprocal, 2 over 1, or just 2. So it's going to be 2 times this. So that's going to get rid of it as a coefficient. So I have x is equal to, and let me go ahead and distribute it to both terms on this side. We have 2y minus 6. So right now, what I'm going to do is, so this equation right here, let me put them next to each other. 2y minus 6 is equal to x. So if y is equal to 1/2 x plus 3, then x is equal to 2y minus 6. All right, so I've solved it for x, and let me actually use the symmetric property to put it on the left side, okay? All right, now the next thing that you want to do is you want to switch around x and y in the equation. Wherever you see a y, you're going to put an x, and wherever you see an x, you're going to put a y. So here, instead of x, I'm going to put y is equal to 2 times x minus 6. So I replaced y with x, so all the y's became x's, and all the x's became y's, okay? So the last step that we have is replacing y in the equation with your notation f, the inverse of the function. So right here we have f -1 of x. So we have, instead of y, we're going to put f inverse of x is equal to 2x minus 6. Okay, so what this does is it takes the input. So if the input is x here, the input's multiplied by 2 and added by 3. Well, this takes the input, multiplies by 2 and subtracts 6. So essentially it's undoing everything that was done in the original equation. Okay, so this is the inverse right here. Okay, so this is the original function and this is the inverse function. All right, so we're going to do the same thing here, but then what we're going to do is graph it after we're finished. So here we take the original function and replace it with y. So we have 3x minus 12. This is the original function here. Then the next thing we're going to do is we're going to solve the equation for x. So here y is equal to 3x minus 12. I'm going to add 12 to both sides. So I have y plus 12 is equal to 3x. And now I want to multiply each side by 1/3 because that gets rid of the 3 as a coefficient. So here 1/3 and 3 are going to cancel. I'm going to have x is equal to, I'm going to distribute this, 1/3 y plus 1/3 times 12 is going to be 4. All right, and let me switch this around the equal to sign. X is equal to 1/3 y plus 4. Now step number 3 is I'm going to switch my x and my y. So this becomes y is equal to 1/3 x plus 4. Okay, and finally I'm going to replace y with the inverse of the function notation. Okay, now when I have this, I'm going to go ahead and graph it. So here I have the y-intercept of 4, so these are going up by 2. So this is the y-intercept of 4 is here. So 2, 4, 6, 8, 10. And since both the x and y axis increase at the same increment at the same rate, so that each of them are increasing by 2 every time, I can just do a rise of 1 and a run of 1, 2, 3. Okay, so a rise of 1 and a run of 1, 2, 3 gets me this equation, or the line. Because that's really going up by 2 and across by 6, which is equivalent to 1 over 3. So here is my inverse function, graphed. Okay, and what you'll notice as a characteristic is that everything that has every point, every xy coordinate on the original graph, you'll notice that you'll have xy coordinates that are switched around. So since the inverse switches around the input and output, what you'll notice is, like, for instance, this graph has an x-intercept of 4. So this point right here is 4, 0. Well, the inverse function has a y-intercept of 4 because the x and y's are switched around. So this right here is 0, 4. All right, let's pick another point. This is 10, 8. Well, that's on the inverse function. So the regular function should have the coordinate 8, 8, 10, which is this coordinate right here. So while all the points on the original function, the inverse function are going to have those points, but the x and y coordinates are going to switch around. So for every x and y on the original function, the inverse function is going to have the coordinates y, x. I know that seems a little strange, but you're going to have what was your original y is going to become your new x, and what was your original x becomes your new y. So that's a characteristic of a function and its inverse. Okay, and that is the end of the lesson for today. So what you learned how to do today was you learned how to take a function, a linear function, and find its inverse. And then you learned how to graph the inverse, and you notice that the x and y coordinates for the graph and its inverse are just flipped around, because that's what the inverse does. It takes the input and switches it with the output. And that's it.